Taking a look at the properties of powers. Recall from our previous lesson, we learned what a power expression is. Power expression has a base raised to an exponent. Now, these rules today are going to tell us how to manipulate and simplify expressions involving powers. So our first one is the product of powers, in which we see we have b to the m times b to the n. Well, notice that they have the same base raised to two different exponents. And when this is the case, all we need to do is add our exponents. So for example, 5 squared times 5 to the 4th is equal to 5 to the 2 plus 4, which is 5 to the 6th power. So when we're multiplying expressions with the same base, we're going to add the exponents. Our next property is known as the power of a power. So now we're taking the power of a power. When we do this, we're going to simply multiply the exponents. So for example, 5 squared to the 3rd power is going to be equal to 5 squared times itself 3 times, which is 5 squared times 3, which is 5 to the 6th power again. So when we're raising a power to another power, we're going to multiply our exponents. All right, our next rule is called the power of a product. Notice we have two different bases, a and b, both being raised to the nth power. Now, when this is the case, we need to make sure both bases, a and b, get raised to the nth power. So, for example, if I had 4x to the 2nd power, then that's going to be both 4 squared times x squared, which would result in 16x squared. So when we're taking the power of a product, make sure we raise both factors to that power. All right, our next rule is the quotient of powers. So again, notice we go back to having the same base. B to the m is being divided by b to the n. The result is b to the m minus n. So here's our example when we have 5 to the 5th power being divided by 5 squared. The result is 5 to the 5 minus 2, which is 5 to the 3rd power. So when we're dividing by the same bases, now we're going to subtract our exponents. All right, our next property is the power of a quotient. So now, again, notice we have two different bases. We have a and b, being divided by b, all raised to the nth power. So notice both the numerator and the denominator get raised to that base. So our example here, if we have x over 2 being raised to the 3rd power, this means that both x is being cubed, our numerator, and our denominator is being cubed as well, and that simplifies to x cubed over 2 cubed, which is 8. So when we're taking the power of a fraction, we're going to raise both the numerator and the denominator to that power. All right, our 0 exponent, you'll love this one. Anything raised to the 0 power is equal to 1. So if I take 419 and raise it to the 0 power, I'm still going to end up with 1. All right, let's take a look at a few examples from our notes and see how we can use these properties to simplify some expressions. Our first one says we're going to take 2x squared y and raise it to the 4th power. So we need to make sure that this power needs to be distributed to each one of these bases. That's the 2, the x squared, and the y. So let's just expand this a little bit. We have 2 to the 4th, we have x squared to the 4th, and we have y to the 4th. So 2 to the 4th is going to be simplified to 16. X squared to the 4th is a power of a power, so that means we need to multiply those exponents. So that's x to the 8th, and finally y to the 4th. All right. Now, let's simplify this expression, 2x plus y squared. Now, this goes back to a few chapters ago when we looked at expanding a binomial. Notice that this is a binomial and not a monomial. It means it has two terms. So when we square that, we actually have to multiply it by itself. And when we do that, we're going to use that FOIL property, or maybe a better way to think about it is just distribution. So 2x times 2x gives me 4x squared. 2x times y is my 2xy, and then y times 2x is my 2xy, and then y times y is y squared. So in the end, we end up with 4x squared plus 4xy plus y squared. Now, this is different than example 1. Notice that we had a monomial, and we simply followed the properties of powers. Here, we need to expand this binomial and multiply it by itself. All right, let's take a look at a few more examples here. We flip our notes over, we'll see example 3, and it says to use the properties of powers to simplify each expression. Our first one, we are doing a multiplication, so we're going to use our property of powers here, and says we have the same base. This is going to result in 6 to the 10 plus 4. So this gives us 6 to the 14, and if you want, you can use your calculator to figure out what that result is. It's going to be a very large number, but you don't need to. For right now, we're just simplifying these expressions. Our next one, you see that we have y to the 4th squared. So again, what this really means is we have y to the 4th times y to the 4th. Then this would be just like our previous problem here, in which we would add exponents, but we get the same result by taking y and making sure our exponents are squared. So this is that power of a power here, and so we have y to the 8th power. All right, in example 3, again we have two different bases that need to be both raised to this power of 4. So we have x cubed to the 4th power times y to the 4th. So we have a power of power here. This simplifies to x to the 12th times y to the 4th. All right, now we have a quotient of powers. And remember, when we have a quotient of powers with the same base, we are going to keep that base and we will subtract our exponents. Whoops, that's 5 minus 3. So the result here is x squared. All right, finally, our last one here in this example, we have this binomial again. There's two terms with the square. So we don't distribute that 2 into both of those terms there. What this means is we now need to expand this binomial by multiplying it by itself, which means we're going to use our distribution property. 3x times 3x gives me 9x squared. 3x times that 4 gives me positive 12x. I'm going to double that because I'm going to have another positive 12x. And then finally, 4 times 4 gives me 16. So in the end, I'll end up with 9x squared plus 24x plus 16. And you might remember from a few chapters ago, this is known as a perfect square trinomial. All right, let's move down and let's try example 4. Again, just trying to remember some of these properties of powers. So what happens when we have 18 to the 4th times 18 to the x equals 18 to the 12th? Well, on the left-hand side, if we use our properties of powers to simplify that, we'll have 18 to the 4 plus x needs to be equal to 18 to the 12th. Now again, if this is an equation, both sides are equal. If our bases are equal, then our exponents need to be equal. In other words, 4 plus x needs to equal 12, and therefore x needs to equal 8. All right, our last example is a bit of a story problem here. It's going to get you thinking back to geometry and taking the volume of some things. So we have this cylindrical can, contains 3 tennis balls. It fits tightly into a rectangular box. It says what percent of the volume of the box is taken up by the cylinder? Well, if we're thinking about in terms of percent, then we need the volume of the cylinder divided by, the volume of the box. Now, the volume of the box is just length times width times height. And the volume of the cylinder is the area of a circle, pi r squared, times its height. All right, so that means we got to do a little bit of figuring out here what some of these dimensions are. So first of all, let's just draw a bird's eye view of this box. So here's the top of the box, and here's the cylindrical can. It fits tightly inside And so all these four spots touch the edge of that box. All right, now let's draw in from the center to the edge of that tennis ball. And let's just let that be the radius of our tennis ball. Well, if that's the radius of our tennis ball, then the length of one side of our box should be twice that, because both of these are r. So therefore, the length of one side of the of the box is 2r, which makes the other dimension the same, 2r. Now, if we take a look at the height of this box here, each one of these tennis balls has a height of 2r, which means if it goes from the bottom of the box to the top of the box, then the height of this box is 6r. Okay, now we have enough information to find the volume of both the cylinder and the box. So let's start with the volume of our cylinder. Pi times our radius, which we're just saying is r, times the height. Well, the height here of our cylinder is 6r. All right, now we're going to divide that by the volume of our box, which is the length times the width times the height. So that's 2r times 2r times 6r. Now remember, when we have the same thing in the top and the bottom, they actually just cancel each other out. So we can cancel out our 6r right away. And let's simplify our denominator. So we have pi r squared all over 4r squared. Well, again, you see that we have an r squared in the numerator and the denominator, so they can cancel each other out. And you're left with just pi over 4, which represents the percent of the can percent of the box that's taken up by the cylindrical can. Now, when you simplify this out to a decimal, you are going to get approximately 0.79, which represents 79%.